thank you all for coming this evening. We've got a real privilege this evening. We've got Ian with us. And the first thing I'm going to do is I'm going to say a huge thank you to him for bringing down some of this most amazing equipment.
Absolutely. Yeah.
It's all stuff that people of a certain age will know, but there are other people of a certain age, people like me, who absolutely love it. And I was thinking on my way down, if you were to compare any of us operators to the equipment, if you were to take, for example, Derrick apart, you would find 4-pin and octal valves, hot caps and a live chassis. Dangerous to work with, but does a good job. If you were to take someone, say, of Alan's or my age to bits, you would find perhaps a couple of valves, transistors, we'd be the hybrids. Brandon, surface mount, forget it. Don't even bother, you need a microscope and a pair of tweezers. All right.
I would say so. Steady on.
I'm not going to comment on that. Right, so anyway, without any further ado, I'm going to hand straight over to Ian. It's a great pleasure to have him here because he is actually a TARS member as well, and we don't see him very often in the club. But for him to come down and do this for us tonight is very, very generous of him, and I hope you enjoy the presentation and enjoy having a bit of a play with the equipment afterwards. So, Ian, please.
Thank you. Well, after an introduction like that, there's no pressure, is there? So, but I have to say, when I left the house tonight, putting these in the back of the car, my wife had a large smile on her face. She thought they weren't going to come back again, which is wrong. So this is a relatively small selection of the ones I've got. I've got something like 50 altogether in working order, and a range of other things as well. And I don't know whether you're aware or not, but there is an organisation called the Eddystone User Group, which used to be a sort of members group, but it's no longer so. Now it's a virtual group. But I'm one of the trustees of that group, and we have a lot of information on Eddystone receivers, and also a lot of information from the factory. And I brought one or two bits of memorabilia along at the back there. You'll see one or two books which were recovered from the factory when it closed. So there's a business's book, there's what's known as an outwork book, and I'll talk about that in a bit more detail later, and one or two other things as well. There's also various bits of ironmongery at the back there, which show some of the innards of some of these devices. Some of them, I think, were probably more mechanical than electrical. And as you can see, they did a great job of supporting the steel industry for quite a few years. So, as it says there, no DSP in sight. There are a few transistors, but no digital signal processing. There is a bit of digital processing, but it's not of the signal. And that's in the receiver you'll see in a moment, and this one as well. But other than that, it's all valve stuff. And it all worked, at least it did this morning, so hopefully it's going to work again tonight. And we'll see what we do. So we're covering from 10 kilohertz to 500 megahertz on a range of receivers here. So hopefully we can hear something on each of those. So I thought what we do is just have a bit of a talk about the history of Eddystone radio, because they've been around a long time and they had quite an interesting starting point. We'll talk about the early years, pre-war, because they were around when radio really first started. They were active during the war, supporting the war effort with the manufacture of millions of components and radios and so on. And then after war, they built most of the ones you can see here. These are all post-war devices. They range from early 60s through to sort of the late 70s, early 80s. So those are the ages covered here. Eddystone did continue to make receivers for a little bit longer after that, but they all went downhill once they were taken over by Marconi's. So we'll talk about some of the defining technical features that makes an Eddystone and makes them so characteristic, how they were built. I've got some descriptions of the sets we've got here, and then hopefully at the end we can have some happy tuning. You can play with them and see if we can receive any signals. So, Eddystone is always associated with Birmingham. That's where it was founded, and it was started in the whole concept of of the business behind Eddystone started about 1860. So there was a bloke called Stephen Jarrett who actually made pins, and he formed a partnership with Charles Rainford, who was a commercial traveller. I think he sold the pins for him. So they had premises in Broad Street. Jarrett also made jewellery, which explains why you've got some quite intricate badges on some of the radios, because that business continued for many years afterwards. They were quite successful. By 1870, they'd moved to Broad Street in Birmingham, and they stayed there for 39 years. In 1898, there was a new starter at the business there, a chap called George A. Lawton, or GA as they called him, and he was at that time 15. He was quite experienced. He'd already had 2 years working in a merchant's office, coal merchant's office, I think it was. And he was obviously quite a good lad at his job, because by 1904 he was an assistant manager with the company. So the business was quite successful. So by 1909 they moved, this time to a location near Kent Street, again not far from the centre of Birmingham, and it's close to where Eddystone's initial works, the Balmoral works, was in Romsgrove Street. By 1911, GAL was running a section of the business, making and selling coronation badges and flags for the coronation of King George V, because much of their business was based on making interesting little memorabilia, badges, things of that nature, jewellery items, fairly cheap things. They used to supply the likes of Woolworths and others, so it wasn't, top range stuff. And they bought a lot of their components in, and a lot of them came in for a company that was proved to be very unreliable, because the owner had a drinks problem. And so in 1911, GAL decided that he'd buy that business for 50 quid, and he called it Stratton for reasons that are not entirely clear. So by 1912, GAL was a director of the company at the age of 29. J&R and Stratton followed their own businesses, Stratton making jewellery and J&R on pins, mainly hat pins. And then during the war years, First World War that is, they made component parts for fighter planes, and they became particularly skilled in the use of aluminium and duralumin alloys, and you'll see that trend through the radios that they built later. They used die-cast aluminium alloys in many of their products. In 1919, the two firms amalgamated and they formed Jarrett, Rainsford and Lawton Limited. Pins remained the main business, but jewellery was now back in production again after the war had finished. So, in 1922, British Broadcasting Company was formed. Had low power, medium wave transmissions, AM, in a number of the cities, and 2LO is probably the most famous one, started in London, and there was 5IT in Birmingham. And GAL had a son named Stratton Lawton, who quickly became a radio fanatic. At that time, radio equipment was very expensive, so home construction was the order of the day, and that led to a market for component parts, and Stratton Lawton saw an opportunity on the horizon to make component parts for the home building of radios. At that time, cinema was also becoming a major pastime and source of entertainment. The Roaring Twenties, I don't think there's anybody here that can remember those, but I am told, were synonymous with film stars and trends and so on. And apparently there was a film called Flaming Youth that starred jazz baby Colleen Moore, and that was very popular. And she introduced what was known as the page boy hairstyle. And the page boy hairstyle, of course, didn't need hat pins. So at the end of 1923, Stratton's market fell overnight by over 80% as a result of that trend, because nobody decided they were going to wear hats any longer, so pins were not needed. So, was it a disaster or not? Who knows? But, of course, I said earlier that they'd started in the idea of making radio components, and so Stratton Lawton suggested to his father that radio components could replace hat pins and so on. And so their first radio patent was filed in 1925, as was the name Eddystone and the Lighthouse trademark. And the company invested in a single British Broadcasting Company share during September 1925. I think there were about 1,200 shares altogether, so they had one of those shares. By 26, they were making and selling components, and the first complete factory-built receivers were being produced. Those were long wave, medium wave, and the Eddystone 2, as it was called, was the first one. It was a straight receiver, no superhets in those days. They were very simple, but they were expensive. About that time, they recruited two influential people. So there was a chap called Harold Cox and Arthur Edwards, and Arthur Edwards G6XJ. And they became technical and sales directors respectively, and they steered the company throughout many years, right through to the 1960s. So something like 40 years of guidance from those two. And you notice they were very interested in amateur radio, and that's one of the reasons why Eddystone was very keen to support the amateur market. That's why they made dedicated receivers like 888, which we'll see later, and the EA12, which were quite famous. So, shortwaves were becoming established in the early 1927 era, due mainly to the pioneering work of amateurs at the time and also BBC. There was a great deal of demand for shortwave receivers from expats from all around the world, and Stratton were in the forefront of producing sets. Atlantic 2 was the first of their shortwave sets, and that was launched in 1927. Rapid expansion followed, and they produced a range of models, many of which were used in scientific expeditions, for example, Arctic expeditions, Hudson Strait settlement expedition, various expeditions in Africa and elsewhere. So they became the chosen receivers for people who were going on those sorts of jaunts. In 1935, they probably were leading the field because they started work on VHF experiments, and they developed a portable 5-meter set of equipment, and that was used on the 1936 Everest expedition. So they were leading the way in VHF technology at the time. Second World War struck, of course, and in the lead up to the war, Stratton were trying to sell the police and the army their VHF sets because they could provide communications in vehicles and tanks. However, it took until 1938 until people recognised that this had promise. So, with war looming, the London Police commissioned Stratton to provide an automatic VHF telephone network. So, working 24 hours a day, they produced a system delivered by July 1939. It had something like 150 individual base stations. So, it allowed the whole of the London area to communicate using VHF radio. So that obviously, if the lines were down, then they could still communicate. And similar systems followed in many of the larger cities. So those were probably the first of VHF communication systems. I wouldn't say they were portable, but they were, let's say, transportable. So during the war, they worked with the Air Ministry. They produced 4.5 million components of various sorts, 4,500 transmitters, over 7,000 receivers, and 45,000 other bits of kit for the police, army, RAF, but principally the Admiralty. And some people here may be familiar with the 358 receiver, which was one of the Eddystone receivers that was used during the war in great numbers. They made almost 7,000 of those. Now, that was despite their factory in Balmoral Street being bombed to the ground in 1940. So everything was destroyed. I think they just had about 2 signal generators and a workbench left. So they had to re-establish everything, which they did. And so they relocated to a site known as the Bathtub, which is a disused Lido, rather, in West Heath, part of Birmingham. And that was their home for many, many years. So after the war, and we're getting into the time when these receivers you see here start to be thought about and produced. Times were difficult because there was obviously a lot of equipment around, surplus from the war, AR-88Ds, CR-100s, all the other stuff like that. And so a decision was made to specialise on equipment, professional standards built very strongly and robustly. And this led to success for many years, and much equipment was supplied to the military and government agencies at home and abroad. And many of these receivers here were used at various stages on board ship, at airports, aerodromes, for a whole range of things. And I think there's at least one person here that remembers using them. So Marconi is a name which you're probably all familiar with. For many years produced radios. They, however, didn't make most of them themselves. They actually subcontracted the manufacture of their radios to others, of which Eddystone was one of the largest suppliers. So many Marconi receivers were in fact just rebadged Eddystone receivers. And so they were one of the largest businesses. GL, that's the old man Lawton, he died in 1964, and the company then was at a crossroads because it was a family business. The main business of the family was making jewellery and other bits and pieces of that nature. And Eddystone was a technologically based business. It was a bit out of step with the rest of the things they did. It also was at the time of the start of the semiconductor age, and so there was a need for a lot of investment and so on. And so a decision was made to actually sell the business, and so it was sold to Marconi's. So it was sold to Marconi's in 1965, and from there onwards it went downhill. So solid state was just beginning. It overlapped with valve technology for about 10 years. Obviously valves are still used in certain applications these days, but in fact they're increasingly used in audio systems, you're probably familiar. People like the sound. And the last valve set that was made was an 830/7. That was made in February, I think it was February 1973. So there was heavy investment in new models needed. Marconi made the decision at that point to pull out of the high street trade. So people may be familiar with the EC10, range of receivers, EB35 and so on. They were domestic market receivers. They looked attractive. They were nice to have all the Eddystone appearance and the feel, but they didn't perform particularly well, in all honesty. But they were quite popular. I think Prince Charles had one of these cars for a while. But they decided to pull out of that. That meant also that they stopped producing equipment for the amateur market as well. So they stopped making the EA12, which was the radio they were making, the last one they were making, and they decided not to make any further specialist receivers for the amateur market. The HF market was falling for a range of reasons. Far Eastern competition was increasing. Many of their radios were sold to ships. Ships were increasing in tonnage, so that meant fewer ships, meant fewer receivers, more competition. Ocean liner travel was replaced by air travel, so all of the cabin sets that they'd been producing, which people would have on board ships, were no longer needed. Satellite communications replaced radio, and so it meant that it was downhill from there onwards. So there was one last attempt to make the business successful, and that was in 1980 or thereabouts. Eddystone partnered with the British Broadcasting Corporation to develop digital audio broadcasting, DAB as we're familiar with, and they developed a successful range of transmitters which were widely used. In fact, they still are used. So hoping for a new life in the digital age, this now much reduced company relocated to new premises in Selly Oak, Birmingham. However, that expansion didn't happen for a range of reasons. The Cold War, reduced government orders, satellite communications burgeoned. Marconi's, as you probably remember, got themselves into deep water. So Eddystone was sold to a company called Megahertz Communications in 1999. That itself went into receivership 3 years later. And that, in essence, was the end of Eddystone Radio. So just before that happened, some members of the Eddystone user group knew that this was happening. We knew that there were spares in the works at Eddystone for all of the receivers that they'd made over the years, and so we bought them. Well, a colleague of mine bought them, and we went to the works and unloaded everything in the back of a van, gave them a few bob for it, and took it off their hands. And now I had all those spares. I bought them from the person that originally bought them, and so I have probably the world's largest selection of Eddystone genuine spare parts. So if anybody has an Eddystone receiver and it's not working, then I'm not guaranteeing I can help you fix it, but I'll have a go. And we do sell spares. I also have remade some parts that have gone out of production and acquired bits and pieces. For example, CFAM, probably familiar with those, just down the road. They made meters for Eddystones, and they made some replacement EA12 meters for me. They also made some replacement meters of a different style, which we used in other receivers. So what we try and do is keep the stock of spares alive so that we can keep Eddystone receivers going as long as possible. So those spares are sold on a not-for-profit basis. So the idea is to keep radios working, so not to make money out of it. It's quite interesting to see where the parts go. I actually send probably on average between 2 and 5 parcels out every week, and probably half of those go overseas. In fact, I've sent a parcel out today to Argentina to a chap who has got 750 and another receiver which he needs some parts for, and I'll be able to supply him with the bits he needed. So, we are trying to do that. The Eddystone user group has got a lot of factory documentation, so we have all the build sheets, we have all the specifications, we have many of the circuit diagrams, original drawings for the printed circuit boards and so on and so forth. So it may not be in a good order, but we have it somewhere, and if anybody desperately needs it, we can probably find it. So there's a wealth of information. It's kept by the trustee. It's not owned by me. It's owned by the Eddystone user group trustees, and it'll be passed on to somebody who's willing to take that on when I take my last shot. So we'll keep everything going as best we can. So that's a little bit of history. So, like many businesses, it has strange beginnings. From hat pins to radios. You wouldn't expect it to happen that, but that's the way it went. And it's a shame, really, that the business went the way it did. I think had they done one or two things differently, had they not abandoned VHF in the way that they did, then they perhaps would have been able to move forward more positively. Had they not sold the business to Marconi, who frankly were not interested in sustaining it, then that might have made things different as well. And also they struck a bit of bad luck, but there's always bad luck in life, isn't there? They placed too many orders with one particular company in Malaysia who went bust, and so that hit them hard. So things might have been different, but they're not. So Eddystone no longer exists, other than there is an outfit called Eddystone Broadcast, which is sort of long lost relation to Eddystone Radio. They still make and supply radio transmitters, as well as other equipment for broadcast stations. But they no longer produce anything to do with the receiving side of things. So Eddystone's quite characteristic receivers. They have a feel and a look to them. So maybe we can just sort of think of some of the things. So obviously the legendary tuning, the silky feel of the tuning wheel. So that's one thing that I think marks them out from most other radios around. And that was always the case with the half moon style of dial, and also with what they call the side rule style of dial. And there is actually a complete front of an 830 actually on the back table there. If you want to have a look at it, you can see the complexity involved and see how they have managed to engineer out the backlash, because there is virtually no backlash in an Eddystone drive. That means you can place the cursor reliably where you want it to go, repeatably as well. So it's a precision-built geared drive, and it has anti-backlash facilities. So two of the big gears are made in 2 halves. They're spring-loaded, so that they tend to move opposed to one another. So that takes up any backlash there is in the gearing. And of course, there's a weighty flywheel as well, which helps the whole thing go along. So it's quite a complicated thing. If you look at the back there, so the drive for the tuning knob goes through a pinch roller to a stainless steel disc, which acts as a sort of clutch to prevent damage by reaching the end stop and continuing to tune. And then it goes through reduction gears, and they offer various ratios, but most of them about 140 to 1. Some of them are different. For example, the A12 is different because it's got a shorter scale, and you'll see the 888A is different as well because that's got a very expanded scale, and you need to make some progress on that. So the cursor moves along a slide rail system, and it's held in place by steel wires which roll on and roll off to small drums, and it's all kept tensioned by a jockey wheel assembly. So have a look at the back if you're interested. So that's a picture of that panel. So you can see one or two features. So you can see the flywheel, you see the pinch roller assembly there, you can see the gears, you see the springs there holding two parts of that main gear part. And this is the drive which operates the peak RF on that particular receiver. There's also, because this is an 830, it's got a second drive here, the incremental tuning, similar pinch roller assembly, the gear, and then there's actually a rack and pinion system that runs backwards and forwards to drive the main incremental dial. And then one of the other things they have is a facility for linearizing the dial. Because, as you know, the law of physics means that the higher the frequency gets, the closer the graduations come. And so you lose band spread as you get towards the high end of a conventionally tuned, that's a, I'm talking about an inductor and capacitor tuned system. And so the linearizing device takes some of that out to make a much more linear thing. Variable selectivity is one of the other things they have, which is quite characteristic of these receivers. And some of them have got crystal positions as well. But the variable selectivity is continuously variable selectivity. And people often ask, how is that achieved? Well, it's achieved by varying the coupling in the primary and secondary windings in the IFTs. And that is achieved by physical movement of the coils within the can. So when you turn the selectivity knob on the front, what you're doing is actually physically moving the relative position of the coils inside the IFTs. Now I've got one of them here. And I'll leave it out later, but you can see it's got two coils in there, primary and secondary. And if you pull this lever, you'll see they move apart. And so that alters the degree of coupling, and it alters the sharpness of response. So it's obviously important to set those up accurately, otherwise it gets into a real mess. You really need to have a wobulator to do it, or frequency, variable frequency device to a frequency sweep device to do it properly. So most of the professional grade sets have a low IF, about 85 or 100 kilohertz. And that helps to provide the selectivity required without the use of crystals. Many are double superhets, and they have a higher first IF to give better image rejection, and the second IF lower frequency to give you good selectivity. So that's the picture of what I've just shown you. So you can see the coils there, and now if you just flick to the next one, you probably see them push close together. So question for you, which gives you the sharpest selectivity? Further apart or close together?
By the knob in the front?
Yeah, knob on the front. So question, which gives you the highest selectivity, when they're close together or when they're further apart?
Further apart.
Correct. Yeah. Because you've got less coupling. So that's how they work. So I think next slide now. So that's a bit of a congested slide, but what that shows is the innards of an 830. So as you can see, it's quite a lot of bits and pieces in there. No printed circuit boards you've seen anywhere. That's actually one I'm in the process of rebuilding. So most of those component parts are new, actually. So all these bits and pieces are new. That's what I've rebuilt. This is the selectivity control rod, and these are the little cams that alter the position of the coils in the transformers. So when you've rebuilt it, you need to set it up properly. So you need to have a frequency sweep device to be able to see what the slope looks like and adjust the positions of each of those cams individually to get the thing as good as you can. So I did talk a little bit about the linearized scale. So physics means that the scales do become cramped at the top end. So if the tuning capacitor operates at a constant rate, so there's two ways you can fix that, either by having a capacitor that doesn't operate at a fixed rate and having funny shaped vanes on it, or have a linearizing system, and Eddystone chose to use a linearizing system. So they have a radial arm and roller system, which in essence adds sort of sine law to the movement. So it partially offsets the laws of resonance, and it makes the scales more linear. And that's used in great effect on the EA12, which you'll see has got an almost linear frequency scale. And that shows the linearizing arm. Actually, this one's on the 830. This one here is on the incremental tuning system that gives you an almost linear incremental tuning readout. So they're well known for being robust, which is good, although if you drop them, they break. But they are robust. That is good because there's a lot of weight there, so it means thermal frequency shift is much reduced once they get warmed up. A lot of the component parts are aluminium alloys, die castings, and a lot of that experience was in-house from work early in their experience. So that construction technique using an aluminium front and an aluminium die-cast coil box, of which there's an example on the back there, was the way they built most of their valve sets, and that meant there was a very robust central structure. Then it meant either side of it they could have lighter sub-assemblies, and that meant that they could have the coil box in the middle, and they could have the IF circuits on one side typically, and then the power supply typically, maybe with a few other bits and pieces on the other. That facilitated the use of sub-assemblies. It allowed them to streamline the manufacturing process, and it allowed them to ease manufacture. But that gradually gave way as they moved to solid-state devices, to a more traditional concept, basically using a thick front plate and side panels. Okay. So a number of the receivers have got turret coils, and this goes back really to the early days of VHF, when it was a lot more difficult to design reliable VHF circuitry and even UHF circuitry. So the 770R, the 770U, there's a 770U here, but not a 770R, and also the EC958, which is this one here. They do have turrets in them, although they're different. And there are some examples of the bits at the back. So the 770 uses what's known as a Geneva mechanism to ensure that the coil carriers are consistently and accurately aligned, because the coils move around, they've got contacts on them. Those contacts need to make reliable contact with the mating parts on the static part of the business. And when they're set up, they're good. When they're not set up, they're no good. I think if anybody was involved in maintaining those, they spent most of their time fiddling around with the contacts on them. So it was a good idea. In practical terms, it wasn't quite as good. The EC958 is different. That has printed circuit boards, some at the back to look at. They're gold-plated, double-sided circuit boards, and they carry the coils and the associated components. And they've got contacts which make contact with gold-plated points of contact on the discs themselves. So there's much more tolerance there, so you don't have to have a complicated indexing mechanism, and it was a lot cheaper to make them like that. So that's a photograph of partially dismantled turret system from the 770U. And you can see the Geneva mechanism on the front there, and that is a mechanism for converting rotary motion into individual stop positions. So there's a pin which locates in each of these slots that aligns the coils with the contacts on the fixed part of the chassis itself. So amazing engineering. As I said earlier, probably more mechanical engineering than electrical engineering went into making these things. So, of course, Eddystone made accessories. We've got a few of them here. So they made S meters, there's one on top of the 888A there. They made loudspeakers of all sorts. They made wedges to support the fronts of radios to make them easier to operate. They made antenna systems. They made a whole host of things.
898 dial.
They made the 898 dial, yes, which people may have.
Lots of receivers of that.
Yeah, that's right. And actually, that's the same dial as is used in the EC10. Except the tuning knob's in a different position. Instead of being in the middle, it's at one end. So, but the mechanism's the same. The bits are the same. And one of the things they did make was a thing called the Edometer, which was basically a dip oscillator, which was presented in a mahogany box and it was quite a handy thing. I've got one or two of them. They're collector's items rather than being particularly useful these days, but they were at one time, in great demand. They also made more significant accessories such as panoramic adapters, which were used for professional range receivers, and particularly in various elements of the signals organisation in the army. So, how were they built? You can see that a lot of individual workmanship and craftsmanship went into them. A lot of the components were manufactured at subcontractors and brought in-house. So a lot of the casting, they didn't do the casting themselves. They used various companies in Birmingham to do that for them. But basically, they were all hand-built. Very few of the receivers were, in any sense, built by any form of machine. So there was no, soldering machines. They were all hand-built. So most of the receivers use discrete components. So it's still possible to fault find and repair them readily. The later sets use sub-assemblies and modules, which could be changed out, in theory at least, speeding the repair, but in practice it takes almost as long to remove the module than it would have done had it not been there. So as I said, a fair range of parts still available, and some new components being acquired and manufactured to fill the gaps. So they all have a very high standard of engineering in them. Probably commercially, too much effort went into the engineering of them, and it meant they were expensive, and they couldn't compete with the products that came from the Far East. So we've got some sets here, so we'll just talk a little bit about them. Go through in no particular order, but there's a 940. That's a single superhet receiver. It's 5 bands, 480 to 30 megahertz. Valves, crystal filter, variable selectivity, but although not with the variable cores, it has tertiary windings in the IF transformers. It's quite a complex design. It's Casco front end. It's got a product detector. It was built as a semi-professional version to fill the gap between the 840C, which people may be familiar with, and the 830 range, which was very much a professional range. It was developed in a short time because they perceived there was a market for these, and they lifted a lot of circuitry from other models to do it more quickly. So it became very popular with well-heeled shortwave listeners, sold all over the world. They made well over 1,500 of them, built between 1962 and 1970. A nice receiver, but lacks some of the facilities which you really need these days, and that's a photograph of one. There's one here. The 830, my view is that's the best valve receiver they made. It's a very capable receiver. It's a HF MF double superhet with a tunable first and tunable second oscillator. It covers 9 bands, 300 kilohertz to 30 megahertz. First IF is 1250 to 1450, so it gives you the fine tuning you see on them, or the incremental tuning. Second IF is 100 kilohertz. Because it's got the incremental tuning, you can set it to within 1 kilohertz, maybe slightly better than that, at all frequencies, without any problem at all. So it has all the bells and whistles. Very popular radio. About 4,000 probably were built altogether. They made various models for various markets. They made also one known as the Stroke 9, which was used with the piccolo tone-based signalling system. I don't know whether anybody here is familiar with that. It was used in the government circles for the diplomatic wireless service and others. So communications between embassies abroad and the UK would be done using this piccolo system. As the name suggests, it is based on tones. So you make a squeaky tone, hence they're called piccolo. But it's obviously very important that the whole frequency of the receiver and also the transmitter is fixed very carefully. And so the 830/9 was used in conjunction with a Marconi frequency synthesizer system. So that removed all the oscillators in the set. They were taken out of service, plugs on the back of it, allowed them to connect this frequency synthesizer, allowed them to make sure that when they sent a T, it was received as a T and not as something else. In my judgment, the crown jewels, the 830, and it was also the last of the valve models made 21st of January, some people say, others say beginning of February 1973. So that's an 830, there's one here, and you can play with that, and it's quite an interesting device. 850, that's a very low frequency and low frequency receiver used in maritime and submarine communications. Covers 10 kilohertz to 600 kilohertz in 6 bands. It's RF frequency change, IF detection, variable bandwidth, got 2 crystal gates. Some were built for use on 25 hertz mains, and the one here, this black one, or the one with the black finger plate there, is one of those. That came from Canada, has a 25 hertz power supply in it, runs at 115 volts. I don't know for certain, but I believe it came from a bunker in Canada that was used for communicating with submarines at sea. So they built the 850-2, which is the one that's here between 61 and 62. Then they built another version called the Mark IV between 65 and 72. I don't know what happened to the Mark III. Perhaps there was one, perhaps there wasn't. But the Mark IV is basically the same as the Mark II. It's got a different style case, and it also has the ability to control the frequency with crystals on 8 spots. So there are very few of those released to the public, and they are amongst the rarest of sets, so they probably made only about 50 of them, and probably only about 25 or so of the one that's here. So there aren't many of those around.
How many have you got?
I've only got one of those. I've got
Only
one of those, the Mark II, and I've got one of the Mark IVs as well. I was going to bring the Mark IV, but when I plugged it in this morning, it wasn't working properly, so I brought the Mark II instead. I was going to bring the Mark IV because it runs off 240 volts as well, needs a transformer. So 888A, quite a famous amateur bands receiver from the late 50s, early 60s. It was actually based on the hierarchy of the 750, which is a general purpose communication receiver. It's a double superhet, first IF of 1620 and second of 85. So pretty low second IF, and it has variable bandwidth, removable coils in the IFT, so it's pretty sharp. It's also got an audio filter and other bells and whistles. So it came in 2 versions, the 888 and the 888A. The 888A has a product detection, 1 or 2 other slight changes to it, so it's a better product. The one here, although it says 888 on the dial, is actually 888A. They used up all the old dials, they didn't bother to change them when they made the 888A. And in its day, it was the set to aspire to, and it was probably the first set that I ever encountered as a kid, because there was an amateur who lived next door to us, I discovered, and he had one of these and a Kodart 85, which somebody may be familiar with.
Out of interest, what was the sort of price at that time?
Well, I think that would probably, when it was bought, it probably cost about 110 quid. So in those days, you could buy a car for about 400. So, and I mean a decent car. So, they were expensive. No doubt about that. So, they were definitely for the, the well-heeled amongst the professionals that were. So they were expensive, which obviously limited the market to some extent. But they were good. As you can see, it's still here, it still works. So, the A12, there's one here. I hope it's working properly. I had a bit of a problem with the tuning on it, but I think if you use it, it'll soon sort itself out. So that's based on the 830. It has the same basic hierarchy as the 830 does. And this harks back to the time when Eddystone were very much in tune with the amateur market, and they were happy to make amateur versions of some of their better professional kit. So it has 9 bands of 600 kilohertz each. It's got a crystal control first oscillator, tunable second. First IF is 1.1 to 1.7 megahertz. The second is 100 kilohertz. So it's got every refinement of the time, including slot filter, variable speed, ABC, and all sorts of things. So they were built between 64 and 69. Few could afford them. Many dreamt of having one. And they were the last of the dedicated amateur receivers made by Eddystone. So have a go with it and see what you think. So that's what it looks like. So you'll find the scale reads the wrong way, as it were. So instead of going up in frequency to the right, it goes down in frequency to the right. and that's because of the way the oscillators are set inside it. 830/1. I was going to bring that tonight, but unfortunately there wasn't room in the car, so it stayed at home. So that was actually a general purpose solid state replacement in essence for the 830, made between 71 and 77, covers 120 to 31 megahertz. It has the same hierarchy as the 830 incremental tuning. It's got analog dials, and it was the first of the sets to move to what is, obviously a more modern style of construction with a rigid front panel and the reduced use of die-cast components. So there are some in there. The coil box is still a die-casting. So actually, that was quite pioneering in its design. It used field effect transistors widely, and it had signal circuits which are very similar to those used in the later receivers, such as 958 and the 1837 ranges. 1837 and 38. 38 was a marine version of the 37. And it used modular construction and printed circuit boards throughout. Never as good as the 830, but a capable set nevertheless. It used to suffer, well, it does suffer from signal overload. So you need to, because it doesn't have an attenuator in the aerial circuit, which is a mistake. So you have to be very careful to get the best from it. That's what it looks like. So quite modern, different appearance to the old traditional Eddystone, but you can just make out there two scales. So there's the top scale, which is the normal frequency scale, and then there's the incremental scale, plus or minus, at the bottom there. And it's got two tunings, one for main tuning and one for incremental tuning. It also had the ability to have up to 50 crystal channels selectable by a switch assembly on the front, which is a plug-in device. So it needs to have that plug-in device fitted, but it doesn't need to have the crystals in it to function. So they were quite popular. They're classed as ships receivers. We used quite a lot on board ships, and were pretty good. EC958, that was probably the most famous of the receivers that Eddystone made. There's one here. So they had various variants, a very successful range, high stability, low frequency, medium frequency, high frequency. They made them from between 69 and 84, although there were many changes through that period. They got progressively more and more complicated, both mechanically and electrically. Tuning system, I like to say, is watchmaking by the pound. They all had fully tuned front end based on a turret system, and it's got interpolation frequency settings. So it actually locks at 100 kilohertz intervals, and then you can tune between those. So it went through a series of improvements. Probably the Model 7E was the biggest step change. That had digital readout to 1 hertz and the claimed frequency stability, resettability better than 4 hertz, they say. Whether that's true or not, I don't know. Probably not, but there we are. The final version was the 95812, which is a beast and a half. That is fully independent sideband capability, so you can receive on upper and lower sideband independently at the same time. And they have a very complicated frequency stability system. It's different from the Waveley loop, which we find in the Raycor RA17 and others, and it's very complicated. So it's beyond the scope of this talk to actually explain it. So maybe at some other stage, if you wish, I happily give a talk on that. But that's what it looks like.
You say it uses the one you do?
No, it doesn't. It doesn't, because that was patented, and they couldn't use it without paying to license it, and so they developed their own system. Its concept is in some ways similar, but it's not the same.
I'm familiar with the ones you do.
Yeah. So you've got, have you got Raycors then, RA17 or whatever?
No, I used the RA17 professionally for 20 years. And one of my exam questions was draw a block diagram of the RA17. You were given a signal, and you had to trace the signal through the circuit, and you had to state exactly what the frequency of the different oscillators.
Yeah. Did you pass?
Well, yes, I did.
Rubbish.
But it was a fascinating piece of kit. The RA17.
Yeah. For my sins, I've got some of those as well.
Oh,
But I don't like to talk about those, so maybe we can give a talk on Raycors later. So they weigh even more than Eddystones.
Oh, yeah.
I've actually got, diverting a little bit, a Raycall set with mixer tubes in it. You know those?
Not the 1217.
No, I can't remember what it was.
Oh, the 1700 series.
Something like that, 1792,
No,
something,
1792.
something like that, yeah.
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 It looks attractive, but it's no good as a receiver. Because it's transistorized and the front end overloads as soon as you show it a millivolt. 1837-2, again, a large family of general purpose and maritime receivers. They were high stability, double conversion. Again, they cover a wide range, 100 kilohertz to 31 megahertz and 9 bands. There's one of those here. They're nice sets. They have variable selectivity, and it has the selectivity is achieved not by moving the cores and the IFGs, but with a fairly complex inductor and capacitor system. So it has a box full of coils to shape the signal. But much of the hierarchy is similar to the 958 and actually the 1830, but it's got digital frequency readout and it's got a high stability provision. Again, it's a complicated system, not the same as that on the 958, but again, something for a later talk if people are interested. So the first IF is 1340, 1360, so you've got a small incremental range. The second IF is 100 kilohertz. So it has free tune and also high stability frequency lock mode, which is supposed, again, to keep the set pretty close to within 5 hertz per day. That's what they say. And that's what it looks like. So there's one of those here. Actually, it's that one. The one that's here is basically new. It came out of a box. It had never actually been opened, and I acquired it about 4 years ago. I think it was one that came from Her Majesty's stores at Donington, is it? I can't remember.
Yeah, Donington.
So they must have found it hidden away at the back there somewhere. So that's where it came from. It's still in its box.
Did it work?
It worked when I got it out of the box, yes, surprisingly. But it failed about 2 days later. Because they're full of tantalum capacitors and they're dead loss. So they keep going pop at regular intervals. So it may not work tonight, particularly as it's got in the cold, so it may not like it. So we'll see. Hopefully it will. But they are nice receivers, and again, good. So I think there's one or two left now. So I've come to the end now, really. So the 770R and 770U. The original concept was to, the government, after the Korean War, they wanted a general purpose VHF receiver, which would cover between 19 and 250 megahertz, I think it was. So Eddystone were asked to make one, which they did. They made a thing called the 770M, but it didn't work properly. It used to oscillate in the high frequency ranges. And so they cured that by actually, instead of making one receiver that covered the whole band, to make two. So they made the 770R and the 770U. So the 770R covers from 19 to 165 megahertz, and the U covers from 150 to 500 megahertz. So there is a U here tonight. Whether we'll be able to hear anything, I don't know. Probably never super aerial, but we'll always try. So, as it said, that's what they did. So the 770R is a single superhet, 5.2 megahertz IF. The U is a double superhet with 50 megahertz and 5.2 megahertz IFTs. And they both were produced in very large numbers. Thousands of them were used mainly in on board ship and also within the RAF networks as well. And they both have revolving turret systems, which I talked about earlier on. So they used to keep people in the maintenance side of the business completely occupied. So that's all I've got to say on the receivers. Hope there's been a bit of interest there.
Not bad at all.
It's I think it's fascinating. I know others don't think that's the case.
Model 830. I want to show a couple working as well.
Computer on it.
Which one are you going to try and link into, Dom?
Oh, so it's not out, but it's not a
It's a real one, you don't need a bloody Yeah, listen, do you want this?
Is that the one with the reverse scale?
Yes. A doddle.
I'm just trying to get a few so I can blink. I thought we weren't using DSP or anything tonight.
No. What Don is doing now is he's gone onto one of the receivers on VLF, and he's going to be looking to try and decode some of the VLF signals that are coming in.
That's an HF signal. I'm on 4.5. That's our wise.
Right, so what are we receiving, Don?
Well, we've got a 50 bow teleprinter.
Bit dots and dashes.
On 4583.
Yeah.
So I'm in upper sideband. So I'm tuned below it. So my two tones are about 1500 hertz.
It's a bit of dots and dashes, Jeff.
Right.
It's a diddy-daddy. And I'm going to put that one back in there. Yeah, okay.
Because if I can, I'm trying to chop it and edit it in.
Seeing anything?
Anyway, look, on the side of that
DDK to Pinnenberg, frequencies 4583, 761, 700.8.